Welcome to Void Realities, a place where the restless mind can drift into stillness. Tonight, we follow a question that lingers at the edge of the universe. Do black holes have a limit, or can they swallow everything? These giants of gravity, born from dying stars, hold mysteries deeper than silence itself. As you listen, let the story unfold slowly, like a tide pulling you into calm waters. Breathe gently, let the weight of the day fall away, and step with me into the quiet, where the universe reveals its secrets, not in haste, but in whispers meant to carry you softly into sleep. Do black holes have a limit, or can they swallow everything? You lie back in your mind, as if drifting into a quiet night sky. Above you, stars glimmer like scattered lanterns, each one a distant reminder of light's endurance. But here, in the stillness, you sense a different presence. Something that does not shine, but waits. A silence so deep it feels like the pause between heartbeats. This is where a black hole begins to appear to you. Not as an enemy, not as a monster, but as a mouth of darkness, patient and immense. Imagine a fabric stretched across a frame. When you place a pebble on it, the fabric curves, drawing smaller grains toward it. Now imagine replacing the pebble with a mountain, and the curve deepens. Replace the mountain with a star, and the fabric dips like a vast whirlpool. A black hole is what happens when the weight is so great that the fabric does not merely curve, it collapses inward, pulling even light down with it. You do not see the hole itself. What you see is the absence, a circle in the sky where no starlight escapes. A boundary, like a shore, marking the place where the universe gives way. Here at this edge, called the event horizon, time itself behaves strangely. From far away, if you watched an object fall toward it, you would see it slow, and slow again. Never quite crossing the line, it would seem frozen in place, fading into red as light stretches thinner and thinner. But if you were the one falling, you would feel no pause. You would cross without noticing the exact moment, moving deeper into a realm from which return is impossible. The horizon is not a wall, but a threshold. It is easy to think of black holes as devourers, as endless mouths ready to swallow everything. Yet in truth, they are selective. They pull only what drifts too near, only what surrenders to their gravity. Planets and stars can orbit safely at a distance, just as Earth circles the sun without being consumed. A black hole does not roam the universe in search of prey. It waits, quiet, at its place, shaping the space around it. The terror dissolves when you see it not as a monster, but as a presence. Your mind drifts now into the scale of such a thing. Some black holes are small, only a few times the mass of our sun, the remnants of stars that burned too fiercely and collapsed. Others are giants, millions, even billions of solar masses, anchoring galaxies like hidden hearts. No matter their size, the principle is the same. Matter pulled so tightly into itself that it becomes a singularity, a point where the rules of physics blur. It is not a place you can touch, not a surface you can stand on. It is a concentration beyond imagining, where density becomes infinite in the language of equations, though the universe itself may whisper a different truth. You linger in thought, listening to the hush. Around the black hole, the fabric of space-time bends like a whirlpool, and light itself spirals toward the mouth. The stars near it twinkle oddly, their paths curved, their light stretched. The hole does not shine, yet it reveals itself by the way it sculpts what surrounds it, like wind, invisible until it stirs the trees. You realize that to understand a black hole is to look not at the darkness, but at its effects. The way galaxies dance around their hidden cores, the way stars vanish from sight, the way light bows in deference. And in this calm reflection, you sense the first question forming gently. If such an object can hold so much, and if its appetite seems unending, Does it have a boundary? Does the mouth of darkness ever reach fullness, or does it always open wider? Your thoughts drift with that question, soft and unresolved, leading you deeper into the story, into the birth of such a presence, born from the breath of dying stars. Close your eyes and let yourself drift backward in time. Before a black hole can exist, there must be a star, a radiant body, glowing in the fabric of night. Stars are not quiet things. They are furnaces, ceaselessly burning hydrogen into helium, balancing two opposing forces, the outward push of energy against the inward pull of gravity. This fragile balance is what allows a star to live. Imagine it now, this balance as a gentle dance. Gravity pulls inward like a hand holding you close. Fusion pushes outward like a breath that refuses to be held. Together, they create harmony, and the star shines steadily for millions, even billions of years. But no dance lasts forever. The star eventually exhausts its fuel, and with each exhausted element, it begins to stumble. You picture the layers of the star, each like the rings of a tree, with fusion taking place in shells as one fuel source is spent and another ignites. Hydrogen becomes helium, helium becomes carbon, carbon becomes heavier and heavier elements, until iron appears at its core. Iron is different. It does not release energy when fused. It resists the star's attempt to keep glowing. At this moment, the dance ends. The breath is gone. Gravity, patient for so long, finally wins. The collapse is swift, merciless, and absolute. In just seconds, the core shrinks inward, matter crushed to densities unimaginable. Around it, the outer layers of the star rebound violently, creating a supernova, one of the universe's most spectacular events. For a brief moment, this dying star shines brighter than entire galaxies, scattering the elements that will one day become soil, water, and life itself. The heavy atoms in your body, iron in your blood, calcium in your bones, oxygen in your lungs, are whispers of these ancient deaths. The universe does not waste. Every collapse is also creation, but the core, the heart of the star, does not escape. Its mass determines its fate. If the star is modest, the collapse halts in time, leaving behind a dense neutron star, a remnant no larger than a city, yet with more mass than the sun. But if the star is massive enough, gravity's pull is relentless. Nothing can resist. The collapse continues until the matter is drawn so tightly inward that no known force can stop it. The result is a black hole. Think of this not as a violent ending, but as a transformation. The star does not vanish. It condenses, condenses, condenses again until its presence is hidden behind the veil of the event horizon. The light that once burned now folds inward. The body that once danced now becomes the silence into which space itself leans. You can imagine the process like the last breath of a singer. The music swells, rises, and in one final note, the sound dissolves into stillness. The silence is not emptiness, but the lingering presence of what was sung. So, too, is the black hole a kind of memory, the echo of a star that lived too brightly, too heavily to continue. As you drift through this thought, a calm question arises. Why do such endings matter? Because without them, the cosmos would lack renewal. Supernovae seed the galaxies with the very building blocks of life. Black holes shape galaxies, guiding the rhythm of stars and gas around them. Death here is never wasted. It is the beginning of something else. You feel the softness of this truth. Endings are not annihilations, but transformations. What collapses gives way to new forms, new paths, new wonders. The breath that ends becomes the silence that allows you to hear more deeply. The star that dies becomes the black hole, a door into a mystery larger than itself. As you linger at this threshold, you wonder, if falling into a black hole means entering such silence, what would that journey feel like? What happens, not to the star, but to anything, even to you, that drifts too close to the horizon of no return? You find yourself floating at the edge of the black hole, at the invisible line called the event horizon. Here, light itself struggles. Here, time bends so strangely that what you feel and what others would see are no longer the same. From a distance, you would seem to pause forever, hovering at the edge. But in your own experience, you continue to fall, gently, steadily, deeper into the unseen. Falling here is unlike any fall you have known. On Earth, when you stumble, you meet the ground quickly. But in this descent, there is no ground, no floor, no final impact. There is only the sensation of being drawn inward, as though the universe itself is inviting you closer. The pull is not sudden. It is steady, unrelenting, soft as a tide that cannot be resisted. Your body stretches with the gravity, though you cannot feel it yet. Physicists call this stretching spaghettification, a word that sounds playful but hides a deep truth. Gravity does not pull on every part of you equally. Your feet, closer to the black hole, are tugged more strongly than your head. Your body, your very being, becomes elongated, as though the cosmos is drawing you into a single line. This is not a violent tearing, but a slow unwinding, as if you are a thread being drawn into an infinite weave. Time, too, behaves differently. For you, the moments pass as they always do. One breath, then another. But for someone watching from far away, your fall would appear endless. They would see you slow, and then fade, as your light becomes stretched into longer, redder waves. To them, you never cross the horizon. To you, the crossing is seamless, unnoticed, like slipping through a doorway without realizing the moment your foot left one room and entered another. The black hole teaches you something profound here. Time is not universal. It depends on where you are, how you move, how you fall. Your time is yours, unfolding gently in your descent. The time of the watcher is theirs, stretched and distorted by gravity's hold. Both are true, and both coexist. As you fall deeper, you may wonder, is this frightening? But in this telling, it is not. It is surrender, not terror. You drift as though into sleep, knowing that the laws of nature hold you, that this path is simply the continuation of a journey begun long ago in the heart of a dying star. The fear dissolves in the rhythm of inevitability. Around you, space curves more tightly. Light bends, arcs and spirals inward, some rays twisting around the horizon in endless orbits before vanishing. You're surrounded by this dance of distorted starlight, a ballet of beams that trace the contours of gravity's shape. The sight is unlike anything else in the cosmos. A reminder that the universe is not only vast, but endlessly surprising. In this endless fall, you realize there is no destination you can point to. There is no surface waiting for you. The deeper you go, the more you are falling into the very concept of gravity itself. It is falling not into space, but into space-time. Not toward a place, but toward a condition. And yet, even here, questions remain. What lies at the very center, at the singularity where equations say density becomes infinite? Is it truly an end, or is it a doorway, a boundary we cannot yet understand? The black hole keeps its secret. All you know is the fall, eternal, silent, and unbroken. You drift with that thought, wondering, if black holes do not exist in isolation, then what of the giants at the hearts of galaxies? What kind of presence emerges when millions, even billions of suns collapse into one? As you drift deeper into thought, the black hole before you begins to grow in your imagination. It is no longer the remnant of a single star, small and hidden, but something far greater. You realize that most galaxies, including your own, carry within their centers a giant, a black hole millions, even billions of times more massive than the Sun. These are called supermassive black holes, and they are not rare. They are nearly universal, woven into the very structure of galaxies. You picture the Milky Way, your home galaxy, spread across the night sky like a river of light. Its arms spiral outward in gentle arcs, but at its center lies something unseen, a presence called Sagittarius, a star. It is a black hole, 4 million times the mass of the Sun, yet all of it confined within a region smaller than the orbit of Mercury. It waits there, invisible, but its influence is felt across the stars that orbit near the core. Imagine standing on a high hill, watching a great whirl of fireflies circle a point of darkness. You cannot see what they are circling, but you know it must be there, because only something with enormous pull could choreograph such a dance. Astronomers see stars near the galactic center race at breathtaking speeds, their orbits curved sharply, betraying the gravity that holds them. That hidden conductor is Sagittarius A star. At first, you might expect such a giant to devour everything near it, leaving only emptiness. But the truth is more subtle, more harmonious. A supermassive black hole does not consume its galaxy. Instead, it shapes it. It helps regulate the growth of stars, drawing in gas and dust, sometimes releasing energy in jets that stream across thousands of light years. Far from being only destroyers, these giants can be thought of as architects, guiding the structure of galaxies themselves. Some black holes flare with immense brightness. When gas and dust spiral inward, friction heats them to extraordinary temperatures, creating luminous disks and streams of energy. These are called quasars, among the brightest objects in the universe. For a time, the black hole shines not with its own light, but with the light of what it consumes, blazing so fiercely that it can outshine entire galaxies. And yet, when the fuel runs low, the giant rests, quiet once more. Your thoughts return to scale, to the staggering immensity of it all. A black hole formed from a star may hold a few suns' worth of mass, but a supermassive black hole, it holds millions, billions. How they form is still one of the universe's secrets. Did they begin as smaller black holes, feeding and merging until they became colossal? Or were they born large in the earliest days of the cosmos? The answers are uncertain, and in that uncertainty lies wonder. You drift closer in your imagination to the edge of Sagittarius, a star. Around it, stars whip in rapid orbits, completing paths in years rather than millennia. You feel their speed like a pulse, each orbit a heartbeat of the galaxy. And yet, from your place of stillness, the motion feels calm, almost meditative. A pattern repeating itself endlessly, like waves returning to a shore. There is a comfort in knowing that even at the heart of chaos, there can be order. The supermassive black hole, though invisible, is a center of gravity, a quiet anchor holding the galaxy together. Without it, the Milky Way's stars would scatter differently, their dance less stable, less bound. The darkness is not absence, but structure. It is the hidden root of the cosmic tree, and so you let this thought settle. The universe's greatest giants are not simply takers, not merely mouths of endless hunger. They are also givers of shape, rhythm, and balance. They remind you that what appears destructive may, in truth, be creative. That darkness itself may be a kind of foundation. You breathe gently into that reflection, and another question rises. If black holes can grow to such unimaginable scales, millions and billions of solar masses, what limits them? Is there a boundary to their appetite? Or could they swell until they consume the very universe that surrounds them? The thought lingers, open and quiet, leading you onward to the next mystery. You rest now with the thought of giants, supermassive black holes, millions to billions of times more massive than the Sun. Their size is staggering, almost beyond comprehension. And so, the question arrives softly in your mind. Do they have a limit? Could such beings keep growing, endlessly feeding until the universe itself is swallowed? To approach this question, you return to the beginning, growth itself. A black hole grows in two main ways. It feeds on what falls too close, gas, dust, wandering stars, and it merges with other black holes when galaxies collide. Each of these processes adds to its mass, like drops of water merging into a widening pool. Given infinite time and matter, it seems the black hole could grow without bound. But the universe does not give infinite gifts. Imagine a campfire on a windy night. If you pile too much wood onto the fire, it chokes itself, the flames smothered by smoke. A black hole, too, has a natural limit to how quickly it can feed. As matter spirals inward, it heats up, releasing light and radiation. This light pushes back against the flow of new material, creating a balance known as the Eddington limit. It is as if the black hole itself whispers, "This much I can take, but no more, not now." In this way, the appetite of a black hole is checked by the very energy released in the act of feeding. Over time, however, black holes can still grow vast, especially during the early universe, when gas was abundant and galaxies collided often. Astronomers have found quasars powered by black holes billions of times heavier than the Sun, existing when the universe was less than 1 billion years old. How they grew so quickly remains one of astronomy's open puzzles. Perhaps they began large, born from the collapse of the first stars, far greater than any that exist today. Or perhaps mergers and rapid feeding built them swiftly. The universe holds this mystery in silence, and you listen. But even if black holes can grow immense, they do not consume everything in sight. A galaxy is vast, with stars spread across hundreds of thousands of light years. Most stars, including your own sun, orbit too far from the center to be in danger. Like planets safely circling the sun, stars keep their paths unless disturbed. The image of a black hole as a cosmic vacuum cleaner, sucking up everything, is not the truth. Its influence, while powerful, fades with distance. And there is another quiet balance to consider. The universe itself is expanding. Galaxies drift away from one another as space stretches. This expansion outpaces the ability of black holes to reach across the cosmos. They can grow within their neighborhoods, yes, but they cannot swallow the universe entire. The very fabric of space pulls galaxies apart faster than black holes can bridge the distances. So there are boundaries. Balances that hold even the darkest giants in check. Light pushing against inflowing matter, distance softening gravity's reach, expansion widening the universe. These balances remind you of a truth that repeats itself in nature. Growth is never infinite. Trees reach heights only their roots can support. Rivers swell only with the rains they are given. Even stars, however bright, must one day fade. So too, black holes, despite their power, are part of this rhythm. And yet the story is not finished here. For while they may not grow without end, black holes hold another mystery. They are not eternal. Just as stars die, black holes too are destined to fade, though on timescales so long they stretch beyond imagination. The physicist Stephen Hawking proposed that black holes slowly leak energy, a process now called Hawking radiation. It is faint, almost ghostly, but over eons it can cause even the mightiest black hole to shrink and eventually to vanish. You let this idea settle softly, like a final exhale. The most powerful objects in the universe are not infinite, not eternal, but subject to time and change. Even darkness itself is temporary. And as you drift with that truth, another thought rises. If black holes do not last forever, then what becomes of them when they fade? What happens when the mouth of darkness closes and silence returns to light? You arrive at the quietest part of the journey, the future of black holes. For so long, they have seemed unshakable, eternal, absolute in their power. But nothing in the universe lasts forever. Not stars, not galaxies, not even the mouths of darkness. The physicist Stephen Hawking once suggested that black holes are not perfectly sealed. Though nothing, not even light, can escape the pull of the event horizon, the very fabric of quantum physics offers a loophole. Tiny fluctuations, particles flickering in and out of existence, appear constantly in empty space. Near the horizon, these pairs of particles can separate, one falling in, the other escaping. The escaping one carries away a fragment of energy. This slow leakage is called Hawking radiation. At first, the effect is unimaginably faint. For a black hole as massive as Sagittarius, a star, the radiation is weaker than the faintest whisper, far beyond anything detectable by our instruments. But time in this story is vast. Given billions upon billions upon billions of years, the steady trickle becomes significant. The black hole shrinks. Its gravity lessens. The mouth of darkness begins to close. You picture this process as a great ember cooling. A star once blazed with fire, collapsed into silence, and became a black hole. Now even that silence has an ending, fading gently back into light. No explosion, no spectacle, only the patient return of energy to the universe. It is not destruction, but release. The smallest black holes, if they exist, would vanish first. They would radiate away their mass quickly in a final flare of energy. The larger ones, supermassive giants, will take longer than the age of the current universe, multiplied many times over. But eventually, even they will surrender. Nothing holds forever. And here you find a gentle lesson. Impermanence is woven into everything. The strongest walls crumble. The tallest mountains wear down. Even the deepest shadows dissolve. In the slow language of the cosmos, black holes, too, obey the rhythm of change. When the last black hole fades, what remains? The universe will be older than words can capture, stretched thin by its own expansion. Stars will long have burned out, galaxies faded into cold remnants. And yet, in this vast quiet, the energy released from the death of black holes will still move, still ripple, still be part of the whole. Nothing is lost, only transformed. Think of your own breath as you lie in stillness. Each inhale becomes exhale, each exhale part of the air that surrounds you. Nothing remains fixed, yet nothing disappears. So, too, with black holes. They are not erased, they are returned. You linger on this thought. Even the darkest presence in the universe has an ending. Not sudden, not violent, but gradual, like a candle burning down to its final glow. It reminds you that endings are not enemies. They are simply transitions, doorways from one form into another. The story of black holes, then, is not only about destruction, it is also about cycles. Of stars dying, of matter collapsing, of silence forming, and of that silence itself dissolving back into light. The universe, in its vastness, never allows one note to play forever. It is always composing, always moving, always transforming. As you listen to this story in your own body, you may sense the same rhythm within you. Moments of light, moments of collapse, moments of renewal. What ends for you becomes the ground for something else. You are not separate from the universe's laws. You are a reflection of them. The impermanence of stars is mirrored in the impermanence of thoughts, of days, of seasons. And in this rhythm, there is peace. The black hole, once feared as an endless taker, becomes a teacher of release. Its end reminds you that even the most immovable forces are not eternal, that nothing in creation is outside the gentle pull of time, and that in the final quiet there is no loss, only transformation. You let the thought carry you. The return of light from the end of darkness is not a collapse, but a gift. And as you imagine the fading of the last black hole, you are left with a quiet question lingering at the edge of sleep. If even the darkest voids dissolve, what new wonders will the universe create in the silence that follows? The story has carried you from the birth of black holes to their quiet fading, from the collapse of stars to the return of light itself. Now you lie here, held by the rhythm of the universe's breath. Every chapter of this journey has whispered the same truth. Nothing is endless, yet nothing is truly lost. You began at the mouth of darkness, where light itself seemed to hesitate. You followed the final breath of stars, their fire collapsing inward, leaving behind seeds of silence. You drifted across horizons where falling is forever, where time slows into stillness. You touched the hidden giants at the hearts of galaxies, steady anchors shaping the cosmos. And you asked if there is a limit, whether black holes could grow without end, only to find that even they bow to balance. And finally, you watched their endings, not in violence, but in the patient return of energy, dissolving into the fabric of space. It is tempting to think of black holes as exceptions, as places where the rules break. But they are not apart from the universe. They are of it. They are not outside of time. They move with it. They are reminders that the greatest mysteries do not erase the laws of nature. They reveal them in sharper relief. As you settle deeper into rest, you may sense that these stories are not only about distant stars and galaxies. They are about you too. You who carry stardust in your body. You who live within the same cycles of birth, change, and release. Your own struggles, your own endings, your own renewals. They mirror the vast rhythm of the cosmos. You're not separate from this story. You are one of its notes. So let the final thought drift with you into sleep. Even the deepest shadows dissolve. Even the strongest gravity releases. And in every silence, there is always the possibility of light returning.